visit. She's not going to be here today.
Yeah, I saw that. That's all right. Okay, this is our 14th meeting, and we're doing lesson 15, which is basically just all questions leading up to the test. So.
Okay, I need to get to. Do we have to download files and everything?
Yeah. I'm gonna open up my Excel file.
Yeah, I gotta do that too. All right, group meeting.
So, are we ready for question number 2?
I'm still trying to pull up the. Sorry, you guys can even go for it.
That's all right. We can wait.
Oh, what the? All right. Okay, you guys ready?
Yeah.
Okay. Let's see.
So for question number 2, I was thinking the first or the third one. I'm not sure exactly which one though.
I got A. Or the first one.
For the first one, right?
Uh-huh.
So 90% of the people have a heart rate between 45 and 145. Since 45 is lower bound and 105 is upper bound. So the 90% is in between that.
Yeah, 90% of all people have a heart rate between 45 and 105. Oh no, I mean, wait a second. Dang it. Wait, isn't it B?
It could.
Wait, for number 2.
Exactly
Sorry.
sure. For question 2.
That's the one that you're on, right?
Yeah.
Are you on question 2? It's A, right? You said you were between the first and the third one?
Yeah, but I'm not 100%. I could be totally wrong.
I think it's the first one, but sorry, I was looking at a different problem. But number 2, I think it is the first one.
We'll go with that.
Okay, Russell's gonna put the third one in case it's wrong.
Okay.
Are these the same questions that are on the? Wait a second. The answers on the practice, I mean the preparation, are in a different order than the ones on the test.
Oh, are they the same? I didn't.
They're in a different order. So for the first one, I got that we are 90% confident that the true mean heart rate is between 45 and 105.
Okay.
But that's for the preparation, and then on the actual quiz, that answer would be the second one. Do you know what I mean?
Yeah.
The answers are like in a different order, so we have to check them.
Oh, okay. I got what you mean.
Okay. So for number 2, I got the answer. We are 90% confident that the true mean heart rate is between 45 and 105.
Right. So the second option.
All right.
Okay.
And for the third one, I got the option, the answer. Wait, did you guys do the preparation?
I did not.
Oh, okay. So I wrote down all my answers for all the questions, but if you guys want time to like read it and like do it yourself, we could like.
It would just be nice to kind of go through each one.
Yeah.
So they did the QQ plots and they were approximately normal. So wouldn't that mean that yes, the requirements are satisfied?
Yeah.
And then the distribution of the mean of each sample is normal since the data has been determined to be normal.
Yeah, that's the one I got too.
That's what I was thinking. So I just wanted to double check.
Did you get that, Russell? Okay. So number 4, are the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Oh wait, on the live video thing, did you get that Russell was here?
Yeah.
Oh, okay.
I think you can show him again.
If not, I'll just write real quick.
There he is.
Okay. For number 4.
I was thinking the third option, confidence interval for the difference of means using independent samples.
That's the one that I got also.
Just because you should do the guys and then the girls, and they're independent.
Right.
You know, they don't go
Yeah,
hand.
they don't depend like. Yeah.
So that's what I was thinking.
That one. Okay. Number 5.
So which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence interval?
Would it be? Yeah, so me and Russell were kind of thinking of obtaining the balances of 90 bank customers rather than 30.
Why is that?
Yeah, the sample size would be larger. And so the
And-
margin of error would like decrease,
Okay.
I think.
Yeah, I think that's right. It sounds right.
Okay, we can just go with it, and then if not, we can
Yeah, it's fine.
figure it out after.
Keep going. Two divided by root of
Oh no, we have to do this.
I have to try to remember how to do this.
The margin of error is the wait a second. What is going on? The margin of error is the like Z score thingy. So this is a 95% confidence interval, so 6.
Wait, so I'm sorry, can you go through how you get that?
Yeah. So remember for like 90% the like okay, I don't know how I don't remember.
8% is just the X plus or minus the standard deviation. Or the mean
That
plus
is to find the
standard.
confidence interval. So we want to try to find the margin of error. And so what we have to do is we have to multiply the I don't remember what it's called, but like Z for the 95% confidence interval, which is 1.96.
Wait, how do you get that? Can you say that one more time?
I don't really remember how to get the Z because it was just in one of the lessons where it said that Z for 95% is 1.96.
Right.
And Z for 90% is
Oh, I think
1.645.
if you plug into the normal probability applet, point
Oh, yeah, that makes sense.
0.95.
And then you shade to the left, I mean the right. I don't really remember what. Oops.
I get 1.645 or negative 1.645 for the Z score.
Okay, it should be like. I'll be back. Okay. It's just the upper two, right?
Is it?
Um,
I mean, it's the same either way.
Oh yeah, you're right.
So wouldn't the z-score be negative 1.645?
Yeah.
So, and then with that, what do we do?
You have to multiply it by the standard deviation over the square root of the sample. I mean the sample.
So standard deviation is 2, but we don't know the sample.
We do know the sample. It's 1,000.
But that's the sample
I mean,
mean.
the sample is 4.
Where do you get 4? For question 6, where do you get 4?
The z-score times standard deviation divided by the square root of the sample. Divided by n.
So z is equal to the standard deviation over the square root of n, and then you solve for n. Is that what you're saying?
No. We're looking for the margin of error. So you have to do m equals z times the standard deviation divided by the square root of n.
Right, but we don't know n. Or where do you?
So in the like little paragraph, it says that a quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects 4 drive shafts made at the factory.
Okay, sorry.
It's
I
okay.
couldn't see that.
So 4 is the n, and the standard deviation is 2, and the z would be 1.
Negative 1.645.
Uh-huh.
I got negative 1.645 to be the margin of error.
I just don't remember what parts of the graph have to be highlighted, or does that not matter? Because if it's positive or negative, that matters, but I think it's positive. I think it's positive 1.645 would be z. Because you have to shade like the left part and then the middle part, but not the top part. Does that make sense?
Okay. So you think it'd be positive.
Right.
But then.
Because it's asking for the 95%, so you have to include everything from like the left of the 95% z-score. Right. So that would be the positive 1.645.
So the margin of error is the same, 1.645.
Hold on, I have to plug it in, but I'm sure you're right. Yeah, so it's just 1.645.
Okay.
I'm pretty sure. And if I'm wrong, I'm sorry. And then the lower bound. So we probably have to plug these in. Yeah.
So when you plug it in, what do you mean by that? I'm just trying to remember. It feels like it was forever ago to find that upper and lower bound.
Well, if we just plug the like, oh wait, this doesn't have a. Oh, never mind. The upper bound and the lower bound. So the 1.645, I think is the.
No, wait. Don't we do the mean plus or minus 2 times the standard deviation to get upper and lower bound?
Yes. So this would be the confidence interval also. Going to be the upper and lower, so it's just the mean minus the z times the square root of n. Times the standard deviation divided by the square root of n. That would be the lower bound. And then the upper bound would be plus. Multiplied by the square root, multiplied by the standard deviation over the square root of n.
1,000 plus
But like this,
1.645 times 2 divided by the square root of 4.
so the mean was 1,000, right? 1,000 minus 1.645 times let's see.
Let me know what you get.
Okay. So for the lower one, I got 998.355.
That's what I got.
Okay. So then we just have to put that in. And for the upper one, all we have to do is add. We got 1,001.645.
That's what I got too.
Awesome. Okay. Number 9.
So for this one, don't we just plug in? So m equals standard deviation over the square root of n, and then we just solve for n.
You could do it that way. There's an equation to find n. It's just z times the standard deviation, and that all divided by m, and then all of that squared.
All of that squared?
Uh-huh.
Yeah, well, that's just the same. It's just switching everything around.
Oh, sorry.
Well, you're not wrong. That's just the easy way of looking at it. Yeah, it's the same thing.
Okay.
I think. So z times the standard deviation over m, all of that squared.
Mm-hmm.
Okay, cool.
Standard deviation is 0.01. 0.01.
I don't know if this is right, but what I got was 27,060.25.
Okay. That's what I got too. But I'm looking on the preparation thing, and it's the same exact question, and that answer is not there. And so what I did on the preparation, I had the understanding that the z for 95% was 1.96. Because in one of the readings, it told us that.
Right.
But when we plug it into the normal probability applet, we get 1.645. So I'm a little confused on that, because if you plug in 1.96 to what we just did, the answer is there on the preparation thing. And so I'm not sure if we need to use 1.645 because that's what the applet says, or 1.960 because that's what it says in the reading.
Well, if you plug that in, then you get 38,416. Is that what one of the answers was?
Yeah, and that's the answer that I got on the preparation when I was doing it. So I'm gonna go with 1.960 as the Z for 95%.
Okay, so then we need to redo these other ones.
Yeah. So if you want, instead of having to redo it again, I did it, and so I got like the upper and lower bounds. So that we don't have to like plug it all in again. I could just tell you the answer, or you can do it for like your practice.
It's not a problem. 1.960 for Z.
Yeah. Which is a little confusing because I don't know why they would like.
So the answer would just be 1.960 for 6.
1.960, yeah.
And
Yeah,
then
1.9.
7, 1,000. Oh, wait.
So number 7 is
1,000 plus 1.960 times 2 over the square root of 4. So 1,001. Well, yeah, 1,001.960.
or what? Yeah, so that's the upper one.
Yeah, and then the lower is 998.040.
Yeah. So it wasn't like that much off, but just because.
Yeah, that's fine. Okay, let's keep going. Question 10.
So then 9, sorry. Oh, crap. It was 38,416, right?
That's what I got.
Okay, that's also what I got on the preparation, and it was there, so. Yeah. Oh, crap. Is there, like, plus side here? I mean, I don't. I have this, yeah. Oh, okay, are you sure? Can you reach it though? Sorry, Jared. Did it? You got it? Oh, next. Yeah, thank you. Okay. So number 10.
So would it be the fourth option?
Yes.
Because they think for the alternative hypothesis that the mean area is less than 1250.
Yeah, that's what I got.
Okay.
11. In a statistical tested hypothesis, we say we reject the null hypothesis.
If the p-value is small, then we reject it.
Yeah. So if the p-value is less than.
Less than the. Got it.
Mm-hmm.
Okay.
Audio. Oh. Okay. Um. All right. Number 12.
What do you guys think for that one?
Um. I think it is no that they don't have enough data.
All we know is that pretty much all the data is very similar,
Yeah.
which doesn't give us a whole lot, so I would agree.
Okay. Number 13. I think this one is. Did you finish reading it?
Yeah, I did.
Okay, I think it's that they committed a type 1 error.
Because she rejected the null hypothesis when in reality it was true.
Right. And I wrote down that definition when I was doing the preparation, and it says that when we reject a null hypothesis, when in reality it is true.
Okay.
The next one. Yeah, that's what I would put too. So for the number 11, we were thinking the first one.
For 11?
I mean 14, sorry.
It's like, yeah,
It's
that's
11 on the preparation, so I'm like,
yeah. Reducing the
Sorry,
probability of committing type 1 means you're probably going to commit type 2.
right. Number 15.
So mean,
So we just have to find out the whatchamacallit. You have to like use the equation, the sample mean minus the mean divided by the standard deviation over the square root of n.
so x minus the mean times the standard deviation over the square root of n?
Yeah. No, divided by.
Divided by the square root of n.
The mean minus x minus the mean divided by the standard deviation divided by the square root of n.
Oh, okay. Got it.
Yes. Well, that's fine.
And that equals what? The p-value? What is that?
Yeah. And so then we compare that to the 0.05, and we find out that the one that we got is a lot bigger than 0.05. So we would fail to reject the null hypothesis.
How many samples? 100?
Sorry?
So I got 1.765.
Right, that's what I got too. And so it's bigger than one. Wait a second. Yeah.
That's
so
bigger than the sample mean.
Right.
Meaning that we're going to reject it. or reject the null hypothesis, right?
No, we fail to reject. Because
Because
null hypothesis would be that it is equal to 1.5 and it's greater than. So we would reject the null hypothesis. I
Okay.
mean, fail to reject.
fail to reject the null hypothesis
Yeah.
because we got a bigger number. Okay.
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 Okay, 16. Yes. Hold on, so I got you.
You would like to look at the mean number of hours worked wage per week by male and female, 100 each. They're different. What is the correct procedure? An independent samples t-test.
Yeah, that's what we got to.
Okay. 17. So this one would be dependent because they live in the same home.
Right. And dependent because it depends, like, if you select a brother, you have to select the sister because it's looking for that.
Right.
So the last one.
Okay.
Number 17, 18, I mean. Okay, so Russell has to go to his lab,
Okay.
but I mean, obviously we're gonna keep working on it, but
Okay. No problem.
man. Okay, so number 18.
All right. So would it be the random soil samples? Would it be the first option? Confidence interval for standard or for the mean when the standard deviation is unknown?
Measured results. Measurements are recorded. I put the opposite.
When it is known?
Because if you plug it into like all that stuff, it gives you the standard deviation. When you plug it into the
Which
Excel sheet thing.
which tab did you plug it into? The paired sample t-test one? Or do I have the wrong one?
Wait a second. The soil scientists collected random soil samples from field, measured it, blah, blah, blah. The measurements are recorded in solid organic. Hold on a second. I did this yesterday, so I could do it again. The dissolved carbon. So there's only one set of data.
I got it. So we
So
do it
in the
quantitative descriptive statistics Excel one, right?
Oh.
Is that what you're saying?
I did it in the one sample t-test for means, but
one sample?
Oh wait.
Oh, sorry. Yeah. I got it.
Oh, okay. I was like,
it wasn't showing up.
on your thing.
Yeah, it wasn't showing up, so it was weird. Sorry. So I got it. So the standard deviation is 4.326. Is that what you got?
Hold on. Yeah. So then we know the standard deviation, so it would just be.
Cool. Okay.
I mean, I think.
So the margin of error.
Determine margin of error for this 95% confidence interval. So we have to use the.
Right. We do the upper minus the lower, and then divide that by 2.
Right. It gives us the lower and upper ones in the Excel thing. The only thing we have to do is the
The margin of error.
right.
Got it.
So the lower one is 11.168.
Well, for the margin of error, what did you get? I got 2.025.
Oh wait, sorry. I didn't- margin of error would be 1.960 times, what's the standard deviation? Sorry. 4.6.
Oh, I was just doing.
I got 1.896. I mean, yeah.
So, remember in lesson
Oh, wait a second.
12? Do you remember in lesson 12 how in the margin of error we just did the upper minus the lower divided by 2?
Oh, yeah.
You remember that? That's what I was doing.
Okay, so the upper 15.217.
Yeah, minus 11.168 divided by 2.
Oh, I see. Yeah,
That's what we did and got it right for that lesson at least.
yeah, we should probably just stick with that.
I just feel like that would be easier if that's a way to do it. Just stick with that one.
Yeah. So 2.0, sorry.
2.025.
2.025, yeah.
Okay, cool.
And then the lower, did you already do the lower and upper?
Yeah, it's just they gave it to us. The upper
Okay, yeah.
15 and the lower is the 11. Yeah. Okay.
15.217. Okay.
Okay, we want to know the difference in mean listing prices between the Hummers. Los Angeles, New York. All right, so let's plug in the data for a 2-sample t-test. Right?
Right.
Okay, just one moment while I copy those. Okay, city Los Angeles. And we're doing the prices, right?
Uh-huh.
Okay, Los Angeles is group 1, right?
Yes.
Or variable 1, I mean. And then New York is group 2. Ooh. Okay, got it.
Okay, hold on a second. I'm just gonna do this again just in case something happens.
Okay.
All right. So the first question says,
Of the 4 types, which is the appropriate one for the situation? Confidence interval for the difference of means using independent samples?
yes. Well, that's what I got to because it doesn't have anything to
Right, they don't
do.
have any correlation. They're completely different cities, so whatever.
Yeah.
Okay, lower bound. What I have on here is negative 423.238.
That's what I have too. Negative 423.2.
And we don't need to change in the Excel file. We don't need to change the type of test, right? Like not equal to, greater than, less than.
No, that shouldn't change the upper and lower.
It should. Okay. So what did you get for the lower?
The lower one, I got negative 423.238.
That's what I get too.
Okay, and then the upper, I got 5,417.336.
Okay, that's what I get too.
Okay, are these ones we switched around to the whole number or still by 3 decimals?
It says round to 3 decimal places.
Oh yeah, you're right. Okay.
Okay.
So now the exercise bone density ones.
Okay, what is the correct hypothesis test? 1, 2, 3 different ones. There's 3 different.
That would be the ANOVA one.
And why is it ANOVA again? Just out of curiosity.
The ANOVA one tests like for a lot of different means, like many different means.
Okay.
Compares means for several groups. And number 26. Oh, wait a second. Okay. Which one are we doing?
We're 26.
Says bone density.
So the test statistic.
Did you plug into the things?
Yeah, I did.
Okay,
I just did. And the test statistic, just clarify, is the p-value or is that F?
It's F.
F. So 7.978 is what I got.
Okay, sorry, I'm just plugging the things in.
That's fine.
Oh, wait. Yeah. All right. The test statistic is. Oh, dang it! I have to do these ones. I got 7.978.
Yep, that's what I get.
Okay.
And the p-value, it doesn't say to round or anything.
7.
But for the p-value, I just put in 0.002.
0.002. Yeah.
Okay, cool. So which of the following best expresses the conclusion of this test? So p-value is smaller.
So we would reject it.
The level of significance, meaning we reject the null hypothesis, meaning that we have insufficient evidence. Correct?
No. So we reject the null hypothesis, which states that they're all equal. And because it was low, we reject that. So there is sufficient evidence to conclude that the mean bone density of at least one of the groups is different.
There is sufficient evidence that the mean bone density of at least one of the groups is different from the mean bone density of at least one of the other groups.
Yeah. Do you understand why?
So, yeah, when we reject the null hypothesis, we have sufficient evidence.
Uh-huh.
And then now why is it that we conclude that the mean bone density of at least one other group is different from at least one of the others?
Right. So the alternative for the ANOVA testing.
Yeah.
From the reading, it says that the null hypothesis is always going to be that the means are all equal, which we rejected that. And so the alternative is that at least one of the means differs from the others. So it doesn't necessarily mean that all of them were different, just at least one of them was different.
Okay,
Does that make sense?
sure. That's fine.
Okay.
So, okay, pressures, da, 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 da.
Is a correct hypothesis test for this? I think that would be the dependent samples test or matched pairs test. Because, hold on a second.
Why would it be dependent and not independent?
So first you like collect the data of the prices that were purchased, like, oh wait, maybe, because if I buy my ticket 90 days in advance, that will affect the price of the ticket if I buy it 14 days in advance. Right?
Okay.
I think. I don't know.
Well, let's try it out.
Oh no.
So the dependent samples test. All right.
Yes, I think so.
So in the Excel document, we do a paired sample t-test. Is that what we do then?
Right.
Okay. So let's do the 14-day.
This is the flights one, right?
Yeah.
Okay, so 14 would go first.
Yep. Okay. And then 90-day.
And then
Okay. So the test statistic that I get is 1.685.
okay, hold on a second. $1.685.
Yes, that's what I got. And for the
Okay,
p-value,
that's also what I got.
okay, that for the p-value for 31, I get 0.096.
Yes.
Okay. Which of the following best expresses the conclusion?
0.096. Sorry.
Yeah, you're good. So because that is
That is less than.
it's just barely less than it.
Uh-huh. So
Meaning
we reject
we
it.
reject it because it's less than.
Yeah.
So we have sufficient evidence to conclude that there is no difference in the mean costs of tickets purchased.
I think that there is a difference.
Or that there is a difference.
Right. Because the null hypothesis states that there. Wait a second.
So there is sufficient evidence to conclude that there is a difference in the mean
Right.
cost of tickets purchased
Yes.
14 days in advance compared to 90 days in advance.
Mm-hmm.
Okay, let's try it out.
All right. Do you want me to turn it in?
I can go first. It's fine.
Okay.
We got them all wrong. I'm kidding.
Oh, I like.
No, but I did get 3 wrong. Hold on.
Okay.
Let's see. Which one did I get wrong? Question 18 is wrong.
Okay. 18.
And question 15 is wrong.
Okay.
And question 12 is wrong.
Okay, 12, 15, and 18.
Yeah,
Um,
is it.
for 15, we put, oh wait, okay. I'll look at 12 first. Get
So
that
for
name.
12, we put that there's not enough data, and that's wrong.
Dang it. Okay.
Maybe no, they don't know the true standard deviations of each sample.
Yeah, maybe. Okay, I'll try that one.
Okay, so for 15 then. Um so the cigarette one, nicotine content's 1.5, but the sample means 1.53. We said that we failed to reject it, but that's incorrect.
This is for 15, right?
Yeah.
Um, okay, let's see. The nicotine content, is there only 2 answers?
No, there's 4.
Oh, just kidding.
For 15? Yeah.
Okay, well, I know for sure that it's not reject the alternative because you would never say like anything considering the alternative. So
So,
we said fail to reject, right?
yeah. What if it was just to reject the null hypothesis?
Yeah, I'm thinking so. So the null is that it's equal to 1.5, and I think we got higher than that, right?
We did.
1.7
We got like 1.765.
Okay, and oh, wait, what?
And then 18, we said that the confidence interval for the mean when standard deviation is known. So I'm guessing it would be the first option instead, that the standard deviation is unknown.
Okay, this is for 18, right?
Yeah. I would say it's the opposite of the one that we picked, so that's why I'm saying the first one.
Okay, I'll do that one. Dang it,
But
I think you told me that too. Sorry. Okay. I am gonna turn it in.
okay.
Hey, we did pretty good though.
Yeah, we only got a couple wrong, and it wasn't like the calculations ones.
Yeah, so we're totally good on that, which is good. Okay, I'm gonna submit it.
Okay.
Cross your fingers
Yeah.
and your toes. We missed one still.
Just
We
one.
missed, yeah, we missed number. Sorry, I'm looking for it. Oh my goodness. We missed number 12.
Okay. So 12, I guess we do have enough information then. So yes,
Apparently.
it's enough that the
Okay.
data for each apartment building are bell-shaped with no outliers or outliers. Sample variances are nearly equal. Or they have a total of 60 GPAs, and also they can apply the central limit theorem. What is the central limit theorem again? I forgot.
That's when you don't have like a large sample number, but oh wait, maybe that's opposite of what I'm thinking. Hold on, I'm gonna look it up. Central limit distribution of sample means is normal when X is normally distributed or when sample size N is large. Oh
Well, the
wait,
sample size is not large.
yeah.
So I think it's the third option then.
Oh, wait a second. But they collect GPAs from an anonymous random sample of size 15 from each of 4 different apartment buildings. So 15 times 4 would be 60. So they do have a large.
That is true. So we'll go with that one.
Yes.
Okay, let me do that. Yeah, we'll just do that. So the fourth option, they have a total of 60 GPAs in all, so they can apply the central limit theorem. All right, and let me just plug in the answers again. Can you just tell me the answers so I can go through and?
Yeah, starting from the first one, obviously, probably.
The question 2.
Okay, number 2 is the second one. We are 90% confident.
Sorry.
Okay. Did you get that?
It's the second one, right?
Right. And then, oh gosh, this is so annoying. The third one is, wait a second. Oh yeah, okay, sorry. The second one is the third one.
Wait, what?
I mean, question 3, sorry. Question 3 is yes, the distribution of the mean of each sample is normal, since the data have been determined to be normal.
Okay.
Number 4 is, oh jeez, is the third answer.
Okay.
Number 5 is the last one.
Okay.
Number 6 is 1.960.
All right.
7 is 998.040.
Okay.
Number 8 is 1001.960.
All right.
Number 9 is 38,416.
Okay.
10 is the last one.
All right.
11 is the second one.
Okay.
12, we're going to put the last one.
Okay. 13.
13 is the first one.
Okay.
14 is also the first one.
All right.
15 is the last one.
Okay.
16 is the second one.
All right.
17 is the last one.
Okay.
18 is the first one.
Okay.
These are going to be in the same order, right?
Yeah, they always are. Yeah. So 19, the margin of error.
Is 2 point. Okay, I was like, wait a second. 19 is 2.025.
Okay.
20 is 11.168.
11.168.
11.168.
Okay. And 21.
15.217.
Okay.
22 is the third one. 23 is negative 423.238.
Okay.
24 is 5,417.336.
Okay.
25 is ANOVA.
Okay.
26 is 7.978.
All right.
27 is 0.002.
Okay.
28 is the second to last one.
Okay.
29 is the last one.
Okay.
30 is 1.685.
1.685.
Uh-huh.
Okay, 31.
0.096.
All right.
And 32 is the second one.
Okay. I think we still missed 12.
We did?
Let me see. Got one wrong.
Oh my goodness.
Yeah, we did. So it is
What the
the
heck?
third option. Yes, it is enough data, or it is enough that the data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal.
What? Oh, we're so smart. Guess what it says? In the
What?
question, it says the data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal.
Right.
So that would be the answer.
Yeah, but we didn't realize that that would just be enough.
Oh, right. Well, and then when I put it in like the Q plot thingy, it like wasn't normal. So I was like, wait,
Huh.
oh my gosh, that's ridiculous.
Pretty annoying.
Oh, whatever. It's okay.
All right. Well, good job. We did it.
We did good. We did good. I'm gonna go back later and fix that because I don't want to sit here and do that. But do you have any questions?
I think I'm good for now. I'll let you know though, when the test comes up close to it when I'm studying if I have any questions.
Okay, sounds good.
Okay. Talk to you later.
Bye. Thank you.